standard 8.F.2. All right. You can read this. If you need to pause the video to do it, feel free. Really what we're going to do is we are going to compare functions represented in different ways, use them to decide maybe higher rate of change, different starting point, all of those things. Okay, so let's move forward here. Let's do this. Let's take a look at the two situations first. So first one, I have George has $20 in his saving, right? It has $20 and is saving $15 every week. Okay. Then I have another one where Mark starts with $20 and his savings are shown on the graph below. So what we want to know is who will have $100 first, George or Mark. Okay. So why don't you go ahead and just you try to figure out what the answer is. Who's going to have $100 first, George or Mark? All right, so let's take a look at this. George, he's got $20 and is saving $15 every week. One is you could graph this, okay? Another one is I could just set up a table, right? So I could say week, right? And then dollar amount, okay? And then so I could say week 0, he has $20. Week 1, he's going to have 35, right? Week 2, let's see, 50. Week 3, he's going to have, what, another 15, so 65. And then we're going to have 80, 95, and then he'll have 110. I think that's right, right? 15, 15. Seems about right. Okay? If I made an error, figure it out. So it's going to take him 6 weeks, right? So we know in 6 weeks he'll have $110. Okay, so we can look over here and we could say, all right, he's got 20, okay, let's see, 0. Well, it doesn't go to 6, right? So we can look at, well, in 3 weeks he's got 50. So we're still not sure. We're gonna have to look to see how many what's happening, right? Well, he starts at 20, right? After 1 week it goes, let's see, it goes up 10 over 1. So okay, so it goes, he's making, let's see, in 1 week it goes up 10. So he's doing $10 a week, right? $10 per week, okay? Well, and we knew this one was $15 every week, okay? So they want to know who's going to get to 100. So in this case, George is going to be the one who gets to 100 first because it's going to take him 6 weeks to get to 100, all right? And over here, let's see, 2, 40, 3, 50, let's see, 4 would be 60, right? 5 is 70, 6 is 80, and I could just stop here, right? Because after 6 weeks, he's already got it. He doesn't. But we'll keep going to see. 7 is 90, 8 is 100. Okay, and we could do that. Okay, another way we could have done this is to look at the starting point, right? They both start at $20, right? $20, and then if George is making, his rate of change is $15 every week, and Mark's is $10 per week. So without even actually calculating where, you know, how long it's going to take, you know that George is going to get there first. His money is going up faster. They start at the same place. He's saving more every week. He's going to be going further and further away, right? So his graph, in fact, if we do this, let's graph George in red over here. So he starts at 20, and then he goes up 15 per week, right? And then up 15, right? So his is going to look like this. So it's going to, I think, be pretty obvious that the red line is going to hit 100 before the blue line ever does. All right, let's take a look at another one. We want to put the cyclists in order from slowest to fastest. Okay, so X is time in seconds and Y is meters traveled. Okay, so who's the fastest rider and who is the slowest? And we're going to go in order. Okay, so Mrs. Johnson, Mrs. Garbosa, Mrs. Spiewak, and Mrs. Smeagag. Go ahead and do that now. Okay, so I'm going to just find the rate of change, right? So this is in time and this is distance. So Mrs. Johnson goes in, right, for 2 seconds, she goes up one meter, okay? So 1 meter in 2 seconds, 1 meter in 2 seconds. Okay, so she's going 1 meter every 2 seconds, which means she's going a half a meter every 1 second, right? So that's for Mrs. Johnson. Mrs. Garbosa is going 12 meters in 6 seconds. So we're going to 12 meters in 6 seconds. So that's equal to 2 meters for 1 second. Okay. And then Mrs. Spiewak is going, well, we look at this. So she's going 1 meter every 3 seconds, right? That's what this is saying. And really the unit rate here, or the rate of change, is 1/3 of a meter every 1 second. Okay, and then finally, Mrs. Smigai, we're looking at this, and I can't really tell. It looks like maybe about 2/3, but let's look here. So in 3 seconds, she goes 2 meters, right? So she's going 2 meters in 3 seconds. Okay, so that's going to be 2/3 of a meter every 1 second. Okay, so if we're going to order from slowest to fastest, then we look and we say, okay, who is the slowest, right? So we've got 1/3 of a meter, 2/3 of a meter, a half a meter, 2 meters per second. Well, Mrs. Garbosa is definitely the fastest, right? So we'll do, let's see, we'll go slowest, right? So it goes, let's see, slowest is, right? Spiewak, right? Then the next one is Mrs. Johnson. Okay, followed by Smigai, and then Garbosa. Okay, right? And we used rate of change on that one to figure out all of them. All right, let's do another one. Assume the rates below will remain constant. Okay, so we're going to pretend that over the course of time they're going to follow the same rate of change. Who's going to win the hot dog eating contest? Okay, so go ahead, try to figure out who's going to eat it and why. All right, so Mr. Grayling, that's the name of our principal if you didn't know that. Okay, we're saying he's eaten 18 hot dogs in 5 minutes, right? So 18 hot dogs in 5 minutes. Okay, so how many does he eat in 1 minute, right? Well, let's leave it like this first right now. Okay, and then we've got Mr. Rutson. Okay, in 1 minute he eats 4 hot dogs, in 2 minutes he eats 8, right? So this one he's eating 4 hot dogs per minute. Okay, and then let's look at this one. Okay, well, Mr. Rutson is going to be faster. Okay, because look, in order for this to be 4 hot dogs per minute, then this would have to be 20, right? But let's go ahead and divide it. So 18 divided by 5, how many times is 5 going to 18? I'm not going to do the long division. This ends up being 3.6 hot dogs for every 1 minute, okay? So in this case, Mr. Rutson will win the hot dog eating contest. All right, based on the information below, which bathtub will be empty first, okay? So go through there and try to figure out which one is going to be empty first. All right, so 25 gallons is draining 1.5 gallons a minute, okay? 1.5 gallons a minute, okay? So it starts at 25 and it's going to empty at 1.5. Let's look at this one. This one also starts at 25, okay? And this one is draining at, let's see, it goes down 5, okay? It's losing 5 gallons in 3 minutes. So let's see, that's 1.6 gallons per minute. Okay, and it started at 25 also. Okay, this one, ooh, nice. This one also starts at 25. Let's see. Let's try to find. Oh, there's a nice point right here. Okay, so then we're going to go down. Let's see, what's my interval here? Interval means the space between the lines. So if this is 25, this is 23, 22, 21. Okay, so it's going to go down 4. Okay, so this one goes down 4 gallons for, let's see, what was that, 3 minutes? Okay, so this one is what, 1.3 repeating gallons per minute. Okay, so now I can look at this and I can say this is negative 1.5 gallons per minute. This one is losing 1.6 gallons per minute, and this one is losing 1.3 gallons per minute. Okay, now the nice thing is they all started at 25 gallons, so I don't have to worry, I don't actually have to calculate it. I can just use the rate of change in order to figure out which one is going to empty, okay? Well, this one will empty fastest, okay? Because it's draining the most. It's doing 1.6 gallons for every minute. This one is close, right? It won't be too far behind. It's 1.5 gallons per minute, and this one will take the longest to drain. Okay, so bathtub B. Let's try another one. Put the cars in order from fastest to slowest. All right. So you figure out which one is going to go, which one, put them in order from fastest to slowest. Go. Okay, so we're assuming miles per hour. This one, that's my unit rate. So I know this is 65 miles per hour. Okay. That's the Toyota Highlander. The BMW 330 is completing a 64-mile trip in 60 minutes. So 64 in 50 minutes. Okay. So we got to get that down to, we got to find out how much it is for an hour. So let's hold off on that one for a second. Let's see about this one. The WRX is, let's see, it's going, let's see, 150 miles. Okay, in 2 hours. So this one is traveling at 75 miles per hour. Okay. And then this one is, oh, here you go. The Ford Fusion, right? In 1 hour is traveling 40. So this would be 40 miles for 1 hour. Okay. So let's figure out this 64 and 50. Okay. So let's see, we could divide it. I'm trying to think if there might be an easier way here to do it to get to 60 minutes. We could divide by 5 and then multiply by 6, or we could just use a calculator. So, and for the sake of time, let's use a calculator. So I'm going to pull out the math tools, which are here. Math tools. Calculator. 64 divided by 50 equals, no, that didn't work. 64 oh, that's how much it is per minute, right? So all right, so it's 64 divided by 50 is it's 1.28 miles a minute. So now I have to multiply that by 60. So I'm going to get 76.8 miles per hour. 76.8 miles per hour. Now I'm going to check that. So let's do this. Okay. So if he's going if the bakers are going 64 miles in 50 minutes, then what I'm going to do is I'm only 10 minutes away. So I'm going to figure out, I'm going to divide this by 5. Okay. So 64 divided by 5, and that's going to tell me how much they travel in 10 minutes. And then I can add that right back onto here. Okay. So according to this, I should get something like 12.8. So it's 64 divided by 5. Okay. So this 64 divided by 5, 64, right? Miles in 5 hours. No, 50 minutes. Okay. And I'm dividing this by 5 and 5. So what it's telling me is how much it is in 10 minutes, right? Okay. So 64 divided by 5 is 12.8. Okay. So this is how much it is in 10 minutes. So 12.8 miles in 10 minutes. Okay. And so then I'm just going to add that to the 64. So it's 76.8. Okay. So we know that in this case, the BMW is the fastest. So that's the first one. Okay. My WRX is very close behind at 75 miles per hour, followed by the Toyota Highlander. And then bringing far up the rear is the Ford Fusion. Okay. From fastest to slowest. All right. Next. The exercise below in order from burns most calories to burns least calories. Okay, go ahead, try that. Okay, so cycling is 10.8 calories per hour. Okay, 429 hours in a 1 hour long yoga class. So that's, wait, hold on a second. Oh, this is minutes. So this is hour. So I got to multiply this by 60. Okay, so 10.8. Yeah, let's do it by, no, I guess we'll do it per minute. Okay, so let's do 10.8 times 60, right? Because that will tell me if this is per hour, then that's 60 minutes. So, math tools, calculator, 10.8 times 60. 648. Okay, so 648 calories per minute. This one is 429 in 1 hour. So Wait, what am I doing here? I'm being a moron. Let's start over here. Okay, this is already set up for me. This is 10.8 calories per minute. Okay, the one I figured out was per hour. Okay, now 429, we'll do 429 divided by 60. All right, let's try that. That should work out better. Okay. Calculator. All right, so we'll do 429 divided by 60, 7.15 calories per minute. Okay. And this one we go, let's see, so it goes up 5, and it goes 205.5 minus 137. So it goes 68.5 in 5 minutes. So I'm going to divide that by 5. So I get 13.7 calories per minute. And then last, I've got one, I don't know what that is, so let's do that. 25 and 4. Okay, so it's 25 calories per 4 minutes. So 25 divided by 4 is 6.25. So this is 6.25 calories for 1 minute. Okay, and then we want to do most calories to least calories. Okay, so my best bet here is cycling, right? No, sorry, running. Running is the best. Cycling is next, followed by yoga, and finally, swimming. Okay. All right. Hopefully you were able to follow through on this. We'll do some more practice tomorrow in class.